think I'm better known for being Colin's father, but I'm Jim Cantrell. I'm CEO of Phantom Space. I can tell you that the rumors of my premature demise are greatly exaggerated. I'm back in the saddle again after some unfortunate news a few years ago. But that's what we do. You know, when you drive off the track and spin the car, you get back in the race. And so we're back in the race here. As far as my background, I started off 30 some odd years ago in the space industry working for NASA and worked for the French Space Agency after that. And that's why Colin was born in France while we were working over there. And then I spent a number of years, because it was a joint Soviet-French program going to Mars. We're building a balloon, by the way. So those of you watching this Mars helicopter that's about to fly, it's kind of a historic thing. We were trying to be the first ones to fly in the atmosphere of Mars. And we built the system, but the Soviets blew it up on its way to Mars. So anyhow, I became a Soviet expert and spent a number of years in the former Soviet Union trying to stop brain drain, scientists going to Iran and North Korea and things like that. So that led to Elon Musk calling me out of the blue in 2001, wanting to buy Russian rockets. That led us to starting SpaceX. And SpaceX started this whole explosion of what we're really all starting to see the benefit of right now is this commercially funded space. Commercial funded space is not new. It's something that's been around for a long time, but it's got a new energy that it never had before. And what I like about it is it's really a middle finger to the man, right? It's a middle finger to all the nation states that thought that they owned the space and that only they could do it. So that inherently satisfies me, but it also I think brings great benefit to humanity, and it brings great benefit to the kinds of things you guys are talking about here. So I'm going to give you a little bit of an overview of Phantom Space and what we're trying to do, where I think we are in the space economy, and how this relates to Nexus. So we've got some pretty cool stuff planned, and I think you'll probably resonate with it. So let me go back to the 1800s. And this is what New York City looked like. If you've ever been there, you know it doesn't look anything like this today. Most of the buildings were restricted to 3 to 5 stories, and one of the reasons being was that people had to hoof their way up to the top. And I suspect people weren't as lazy back then as they are today, but still, to climb 40 or 50 flights of stairs daily would be quite the feat. There are places in Italy I know where people do that, but it's rather unusual. So this was limited by the fact we didn't have something called elevators. And what that did to the skyline of New York City was dramatic. And what really elevators did was they expanded both the economy and the real estate vertically on the island. So it was waterbound on all sides, but the economy expanded vertically through the use of elevators and more floor space. So you can imagine how much commercial floor space came into being because of skyscrapers. And these aren't necessarily ego sort of devices. They do resemble rockets in a strange way, but they expanded the floor space vertically. And essentially that's what the space economy is going to be doing. And that's why I think that the elevators are the rockets of yesterday. So tomorrow's space commerce is going to be different, I think, as well. Today, it's very hardware centric, takes a lot of capital to do it. It takes years to put it in place. Very typical of hardware, right? And I noticed Colin's comment on the old internet and the software-based protocols versus hardware-based. We're still literally talking to our satellites like bulletin boards and computers in the 80s. And the space industry has a lot of growth potential because it's relying on very old technology for reasons, but that's changing very quickly. And I think tomorrow will be very software centric, which means that a lot less money has to go into starting enterprises in space, and you can do it very quickly in terms of months. So this is really what Phantom's about, is trying to prepare the infrastructure for tomorrow and doing what we think is necessary in that regard. So there's a disruptive technology that's going on, and you probably all have heard about the microsatellites, and really kind of an outgrowth of these small phones we hold in our hands that become, in some ways, almost weapons of war. Right? They're so powerful. You can be tracked. You can track other people. You can start Twitter wars. You can start real revolutions over Twitter. It always seemed the phone's used for all sorts of things. That technology is finding its way into space, and it's displacing what traditionally were very large satellites that took a lot of time and a lot of money, just like the traditional space. So this is becoming very, very disruptive in the business, and it's driving a lot of things forward, a lot of other technologies and capabilities forward that people didn't see even 5 years ago. So what I want to say too is that space will become part of our transportation system on the Earth. When you say, transportation system, normally you think of buses, think of cars, you think of ships and airplanes and so forth, trolley cars if you live in a city. But rockets are going to become increasingly a part of that. They already are. We're transporting some people into space, a lot of satellites, but the future holds a place where rockets will be transporting people and goods from point to point on the Earth, as well as assets from Earth to space. And I believe in a not so very distant future, maybe 20 years. So hopefully I'll live that long to see it. But we'll see not space tourists, but we'll actually see people going into space to actually do work in a meaningful number, not novelty astronauts that we see today, but people that actually go there. So this is going to become gradually an integrated part of what we do as humans. The interesting thing for me is that yesterday only nation states did this, and it's kind of like currency, right? It's kind of like cryptocurrency in a way. Cryptocurrency is this great disruptor. Microsatellites are sort of the equivalent in the space world, because they've been able. It's made it such that the ordinary person can do what only nations used to do, and that's extremely exciting. It's very promising. It's easy to get sort of down on the world and think about all the bad things that go on and bad things that are happening. But I try to take an optimistic view. I have no choice, right? I take an optimistic view of the future that gradually we can take and destroy the nation state dominance over our lives by what I call the halon effect. You don't take the nation on frontally. You essentially take the oxygen away from it. So in terms of the wasteful spending I see in defense and space exploration, if the commercial capabilities emerge, the nation states aren't going to build that stuff anymore. They're just going to buy it. And I like to joke that if the United States and NASA could build an iPhone and get away with it, they would, but instead they buy them. So that's what I mean by the halon effect. You just gradually just make them irrelevant, and they become irrelevant, they go away. So today we've got this great dynamic that's happening. So the private sector is not only doing what the nation state used to do, but they're doing it better, and they're doing it more efficiently, and they're it's creating a huge public interest, which I'm really happy to see. So I'm guessing the majority of you out there are a lot younger than me, so I'm going to say your generation has a renewed interest in space that really warms my heart to see. So that's something that didn't really happen prior to Elon and SpaceX, and I think we owe part of it to them and how they've done this. So they're also launching astronauts, which privately, these are privately built rockets. I had no idea when we started SpaceX we'd ever be launching astronauts. I thought, a pipe dream to put a satellite up, given the kind of money we had and resources and crappy facilities and so on. But here they are, right? So my hat's off to these guys. They've done a fantastic job. But really, we're still at the very beginning. I like to use the analogy that this is a frontier economy that we're marching into, the space economy. And it's much like what the New World was in the 1500s. So Columbus, went over to the New World in the late 1400s. And think about that for just a second. That was at the end of the Dark Ages, right? It's the beginning of the Renaissance, really. And, the Dark Ages were so bad in terms of scientific discovery and religious persecution and so forth. These men got in a boat and they went all across the ocean, not knowing where they're going to go, landed on the shores of this continent that I'm presently on, and came back with tales, and that led to this infinite loop of discovery and value creation. And at that point, if you're standing on the shores of Spain in the 1500s, there was no way you could imagine what value was being created in the New World, or what would be created in the future. And so much of the same here. We're talking about trillions and trillions and trillions of dollars of value in the space that's going to accrue, and we're just at the very beginning. So this is what gets me up in the morning, besides race cars, and it pushes me forward, is the idea that we're at this very, very early stage, and that we can not only become shapers and movers and create value, but it's something that we can leave a legacy behind with. So with respect to Phantom specifically, we decided that massively valuable companies are still being created in space transportation. We said, look, we don't know what the killer app's going to be in space, just like nobody really knew what was going to happen in North America or South America for that matter. And but I do know that I need to get there. I need to move space assets around in space, and I need to be able to bring it back. And then, sort of along the same lines, we need to be able to do the same thing with bits. So that's that is really what we're trying to create, is that infrastructure. So the opportunity is huge in terms of finances, and some people sort of roll their eyes at money, but it's the lifeblood that makes this whole thing go. And where there's money being created here and value being created, that attracts capital. That allows us to do the things we like to do. So the 2020 market is about 600 billion, 570, something like that. It's going to be 2 trillion by 2040. I think that's actually an underrating of it. It's growing very, very, very fast. So this is what we're looking at, is launch, satellites, and then moving data through space, all of which are very large markets. And so sort of strangely, we're starting with the smaller market, but it's the most strategic out of all of them. If you don't own launch, you can't dominate the rest of it. And so that's one of our real reasons for being in launch. So what I'm looking to do is to replicate what Henry Ford did in the auto industry, some 100+ years ago, and go back in time again, kind of like the New York skyline. That was about some of the first cars were in people's minds, and 10 years later, there were a few of them running around on the streets. But Benz said famously that only 2,800 cars would ever be sold annually in the world, because that was the limit of the skilled drivers out there that could operate the vehicles. Talking about short-sighted thinking and sort of, I don't know, maybe sort of superiority of the thought process, that they were somehow, the only ones who could ever learn this, is sort of maddening in a way too. But Henry Ford came along and said, look, I think I can make an automobile that even my employees who assemble them can afford. And so $400 or $500 for an automobile, where the ones being made in Europe and some of the high end ones here in the United States were upwards of $8,000. So he set about doing this through mass production, and not only that, but he was a son of a bitch from all accounts, and a pretty conservative son of a bitch. But yet he guaranteed a living wage to his employees, and I can't remember the number. It seemed like it was $5 a day wage, something like that. But it was a good 30-40% above what they would expect to make elsewhere. So he created this whole economy, changed the world in a lot of ways that most of us don't think about anymore today. Being able to get into a car and go anywhere is a pretty powerful thing. It empowers the individual, it empowers thought, it empowers innovation. All these things. It's the core infrastructure for the way we operate as a world today. And Henry Ford started it. So we're going to build things that include launchers. We're going to build satellites, and we're really trying to treat satellites as a service. Interestingly, there's about 2,500 satellite manufacturers in the world today. When I first graduated from college, there were about 8. So those are proliferated, but still, it's a very very small number of people in the world that know how to make these little magical things work. They're not really that hard, but there's a lot of hard-learned lessons there to making them operate. And so our theory is let's do this for a lot of these people who otherwise have good ideas, and to try and create, much like software, create the basis to which they can put their creativity on top of it. And same with launch systems, by the way. I mean, there's maybe 10 good launch companies in the world. So they're even rarer, which is why that's so strategic, but ironically, a smaller part of the market, as you saw. And so once we're there, in space, we offer a number of propulsion technologies. We're working on some pretty advanced electric propulsion, and we're selling some of those already. And then finally, our space data infrastructure play, which is ultimately the reason for Phantom, is to create a superhighway for data in space. And we'll do that with our own hand-built satellites. So we start then with the next generation of micro launchers. There's really only one out there that's operating. It's out of New Zealand, Electron by Rocket Lab. And I helped them in the early days. Good bunch, but really too small of a rocket. When we came along and started Phantom in October of 2019, we started with a clean slate on the design and on the market, and said, what is the most profitable vehicle we can build, and regardless of size. And we went all the way from a Falcon 9 down to 0 to something about the size of the Electron. And we came up with our Phantom Daytona, which is sized to put about 1,000 pounds into orbit. Turns out market-wise, that's what they're looking for. That's where the market growth is expected to be. And it's still a small launcher. It's about 60 foot tall and about a 4 foot in diameter. So it's a smaller vehicle, but it's about 3 times the payload capacity of the Electron, and I can do it for half the price. So we call this the Kiwi Killer. So why are we different than the rest of them? Really, it's a couple of things. One, we're the only ones really looking at mass manufacturing. I can tell you, when we're designing this rocket, and we're in the middle of it right now, we're looking at, not how do we just build a tank, but how are we going to build thousands of these tanks? And so our designs really are made for manufacturing, and we're using as much industrial components as we can. My vice president of manufacturing ran a car company. At one point, he was on the floor doing the manufacturing line for low production, but still in the thousands car company. Nobody else is doing this. We're the ones who uniquely have this capability. And I can tell you in this industry too, it's one that favors graybeards. Your industry in crypto and software, young people are much better. But in our industry, where shit blows up, you're better off having the guys who've blown a lot of things up, survived with a few scars, and know what to avoid. So we're the only ones really, we think, that are credible in this, and also being able to launch them by the hundreds, which is no small feat, will actually be the throttle on launching. So we have a mobile launch infrastructure, so we don't have to sink a lot of millions of dollars in the concrete and launch sites. We're an all-American supply chain because a lot of the government contracts that we think will be a part of our sales basis will be requiring this. We know that is. And finally, our satellite mesh network, which we call Phantom Cloud. So the other thing we did uniquely on this was, we asked ourselves, should we follow SpaceX and everybody else that's followed SpaceX? And should we develop every technology ourselves, or should we go out and look and see what we could buy? And I can tell you, one of the things in my life that served me well is when I see a crowd running in one direction, I usually go the other, because I figure, when people say, can 10 million Frenchmen be wrong? I ask the question, can 10 million Frenchmen be right? And so I try to do something different. So everybody that's in SpaceX has always copied their way of doing it, which is to design everything from the rocket engine to the flight avionics to the software themselves. So we went out, we found some rocket engines that actually had already been qualified. Ursa Major up in Colorado, and they had saved us really $5 million or $50 million in 5 years. We've acquired critical technology. We bought companies. We've filed some patents ourselves, but we've also licensed IP from the likes of NASA. We got our avionics system from NASA, all the flight software. It was a program that they had started. They flew it a little bit for a small launcher, and then they gave up and they're licensing out. So what we've done is we've been able to take this 7-year development cycle on a rocket and crush it down to about 3.5 years. And we're almost 2 years into it now. And I can tell you, we've hit our marks on schedule. We've been very, very, very quiet on purpose till now. And we've hit all our marks for very, very low amounts of money. and the strategy is working. I think at the end of the day, it allows us, the founders, to keep control of the company and keep the critical decisions out of the hands of stupid assholes who don't understand how to make them and don't understand the industry. And sometimes those people can get control of the company. And you really, I think in this business, if you've got the long view, and this is a 10-year play, we've got to maintain control. So that's been very important to us. Our competitors are out there, but we're really going after SpaceX, right? I'm going to go take a chunk of the SpaceX market share, and I'm going to run away with it. And I'm going to do it in such a way they can't compete with me on cost. And there are costs to launch on a SpaceX vehicle that we don't have. So they can't control those factors. And so I think it'll be very hard for SpaceX to retaliate against us. And in a sort of an ironic twist, we have a version of their Starlink, but we won't go head to head with them on that. I think personally, I don't think their market's a viable one. But who am I to know? I've always been wrong about Elon, so I'll just let's keep that one to myself. Our timeline, we've been, since we started in 2019, we've actually had a satellite we're building. It's about to go out the door in a few months. And it's a radar satellite, and it'll fly up late this year, early next year. We've got 2 other satellites under contract that we're working on now. Our first launch will be either December of 2022, or it's probably more early 2023. We'll also be putting our first satellites for Phantom Cloud up in 2022, and we hope to establish a minimum viable constellation by 23. And we'll enter mass production by 2024. So I can tell you, I spent the morning leasing a very large facility here in Tucson for our production. So things are falling into place, and it's looking pretty good. Every day seems to get just that much better. It's a company that seems to be fueled by serendipity, which is a great thing. So here's the Phantom launch vehicle family. Our Daytona is our first one. Like I said, it's about 1,000 pounds to orbit. It's fully expendable. We have another expendable version that's slightly larger. It'll be about 2,200 pounds to orbit. We call it the Laguna. And if you're wondering, yes, these are named after racetracks. My co-founders indulged me by doing this, and we thought it was kind of a cool naming strategy. Finally, our Daytona-R is a reusable version of the Laguna. And it's a slightly reduced, significantly reduced mass to orbit, but it's really made to be an upgrade to the Daytona-E with a reusable first stage. And what we're planning to do, we're going to bring them back pretty much like SpaceX does. But there's 3 reasons why we're doing this. First, if you're dumping these things off in the ocean like is traditionally done right now, if you had 100 of these things floating around at any one time, I give you 3 guesses as to what countries might go fish them out of the water and reverse engineer them. So there's a national security problem there that I just don't want to deal with, number 1. Number 2, it's pollution in the ocean. Number 3, most important, is in order for me to expand my launches to hundreds a year, I believe that I'm going to have to expand beyond the traditional launch ranges which we have now, which are on either the west coast of the United States or the east coast of the United States. And that would be places like Texas, New Mexico, Oklahoma. They have spaceports, but they're only licensed to launch horizontally, which means that you recover the first stage back. And so if we can reliably demonstrate that, then we'll be able to launch out of the middle of the country and bring the first stage back, either reuse it, throw it away, whatever. But if we bring it back, it's much more like an aircraft operation than it is a rocket operation. So that's what we're trying to do, is to make this sort of thing regular and an everyday event. So this is a little bit more rocket porn on the Daytona-E. We've got 7 5,000-pound engines, and they're actually absolutely works of art. These little engines, I liken them to a Ferrari engine. It's about 30,000 pounds liftoff weight. So traditional aluminum structures. There's nothing really magic about this thing. We've just got to get it together and make it work. So, we're building all the structures, and we're getting most of the electronics from Otherware and finishing the software off from what we licensed from NASA. And we're moving along pretty fast on this one. You can see here in the middle, the engines, the one on the left is our first stage engine, which there's 7 of. And then the one on the right is our second stage engine. We actually have one of those in our shop, been delivered. We're got these guys under contract. They're delivering engines as we speak. And you can see our little flight computer on the bottom right. And these are not real drawings of the vehicle. We actually can't show those because of government regulations. But at any rate, we put together some notional views of these things that we can throw out because they're not real. This is real here. You can see a number of these engines being produced for us. They're being mass produced up in Colorado. You can see the testing of these engines that they've done. These things, like I said, are ready to go. So they're completed on qualification testing, and we're off to the races, as they say. Our Laguna, just a bit bigger, with bigger engines that are under development and are some major. They're not done yet, which is why we didn't go straight to this, by the way. Again, it's traditional aluminum and so forth, designed for mass production. Pretty much the same vehicle, just bigger. We're going to do, like I said earlier, mobile launch ops. We designed a uber cool tracked vehicle for transporting the rocket out to the launch site and erecting it. This is designed by my friends in Rusk, Texas, who built a number of race car frames for me in the past, and we just hired them and said, "Hey, this looks like something you can do," and they did. So we'll be starting the production of that probably later this year. Our operating strategy is to start off with as many existing sites as possible. I'm happy to tell you that we are now the proud owners of a launch site at Vandenberg Air Force Base, Slick 5. It's an old NASA launch pad. We're working on that at Cape Canaveral. I'm heading out to Florida next week to hopefully help put the deal together there. We have our headquarters here in Tucson, which will also be our main manufacturing and mission operations. Then we have future launch sites in Alaska, and then inland, maybe Oklahoma, Texas, and New Mexico. We're talking about 7 launches in 2023, 14 in 24, and doubling from thereafter. And we'll start off with the traditional launch sites, but then the non-traditionals will probably be about 2028. So then Phantom Cloud, this is powered by Nexus, and I've been working with Colin and all of his colleagues, and it's been a great relationship. And we've come up with this idea of tokenized satellites running off of Nexus tokens. And basically the idea is that we create a cloud based mesh network in space. And instead of this, as I describe it, VBS style, one at a time dial up the satellite, that these satellites are then hooked to the space-based cloud at all times, can exchange data with it, and in the process, much like cryptocurrency, are stripping some of the tokens off for passing the data through, and can get their data back to the ground to a simple end user over a PC. We'll take care of the traditional ground communication system because we have a mesh network of these. It looks seamless to the end user and can sort the data. And we also put mobile, handheld, and fixed station capability so that we can talk about having not just satellite operators sitting at a desk with a computer, but eventually handheld devices so that they can access it anywhere in the world. And it'll be an evolving capability that we're going to encourage others to create their own satellite. Ours are in the dark blue, and the ones created and funded by other people would be in the light blue, and to become a part of this mesh network so they would participate in exchanging data and would gather the revenue from that, which helps continue this. But that would be all powered by the same software built by Nexus, this operating system. So then, third-party satellites that have imagery and we'll just call it source data can then also hook into this and send their data down. So it's sort of a more practical version of Starlink. Starlink is really aimed at the consumer, which you can argue is where all the money is. But actually, I think the B2B side of this is where all the money is. And what I see here is also it sort of thrills the libertarian in me that we can also get around some of these these internet what do we call them? I call them assholes, but they control the flow of information. Like in China, they've got the Great Firewall of China, the censorship. There's this bullshit that's going on in the United States right now with censorship. We're going to create something that's decentralized here that nobody can control the flow of the data, and it's a free flowing system. There's not going to be a massive off switch here, and it's guaranteed by the fact that independent people can come in and add their nodes to it. So it's never going to be in the interest of the core system to disable the other nodes and disable certain data channel flow. So to me, it's a beacon of liberty, potentially, that if we do it right, we can create that out there. So it's ultimately, for me, if I leave a legacy, this is the one I want to leave. So Phantom, today we're making a lot of progress. Like I said, you can see some hardware here. When I was at Vector, some of you may remember Vector. I barely remember it. But we created a test site out here in north of Tucson. We're in the position now of recovering that test site, and we've been working with the county officials who own it, and we'll be having that. That's in the lower left-hand corner. We have the launch site in the lower middle, which is out of Vandenberg. You can see some of our tanks on the right that we're building for the launch vehicle. You can see some of the tests that were done up in Colorado on the engines, and at the top middle, that's one of our satellites we're assembling there, and it's tested on the left-hand side. That's part of it. So we're making a lot of progress, and very small group. Now we're a small little army, but we're fierce, and we're very effective, and we're poised to really get this one done. So hopefully this is what it looks like tomorrow. Again, it's a rendering. We borrowed one of NASA's images for this, so it looks uber real. But this is what we hope to be doing, is building, shipping out rockets by a commercial truck to all the places around the world that we launch these things from. So that's it. And I don't know, let me see, I'll look at the time here. Yeah, we've got about 15 minutes. If anybody has any questions or anything.
Yeah, we have one question that came through. It says, as far as materials, has Phantom Space looked into element neobium to mix with the metals and help lighten and make it more durable and corrosion resistant?
Yeah, niobium. Yeah. No, we've been terribly conservative on that sort of thing because we don't want a science project. It's not to say we won't do that in the future. We've avoided carbon fiber composites, for example, and at these sizes, they just don't trade. We don't run a lot of pressure in the tanks, for example. So it's more about, it's kind of like a beer can or a pop can. If you stand on it and it's full of fluid under pressure, it's stable. But if you take the pressure out, it collapses. That's the kind of stuff we worry about. It's elastic stability in the rockets. So we're more worried about that than strength, believe it or not. And then how do we manufacture these things? So, we're trying to keep the touch labor down to the kind of guys that, we can pay $25 an hour to, rather than high-powered people that have specialty knowledge. So good question. Probably, at some point in the future, we'll be venturing out to more exotic materials. But for starters, it's just plain old 5000 series aluminum.
Awesome. Do we have any more questions come through? No? All right. Well, I guess since we have 10 minutes, I just cover some of the ones I didn't get to in mine. I'm going to, there was a couple questions that were kind of coming in, and maybe we can both kind of tag team some of this. They say, how much of this is already coded? What is to come? We're using the SEL4 microkernel, which essentially it's a formally verified microkernel. You're actually pretty experienced with it, Dad, too. And I mentioned that they've used it on military applications to prevent drones from being hacked because they have certain memory policies in how they handle the memory allocation. And that's a really important part, because we're not only providing this new type of cloud, right, but we're also providing a new level of security, and that also embeds directly in with the IoT. So this is another part of the business to business, practical applications of this Phantom cloud. And then obviously the serious one that we're doing, and the initial, just so that you guys know the relationship and how it forms, is that the maturation period, if you read in the white paper, is a kind of beta period where there's, the system's going to be locked from outside, nodes joining the network for a period of time. And that first maturation period is going to be, Phantom building their cloud. And then we're building a space DAO, actually called Serious Technology and Research. It's STAR is the acronym, and that's we're going to be working in. So if you want to get involved on like actually owning some of the tokenization, getting involved on the space aspect of it, that's going to be a co-op, and we're going to drive that through Nexus. But then our two constellations are going to interoperate with one another, and Phantom is going to focus more on the business to business, and we're going to focus more on the individual consumer, right? But when the first phase of this operating system comes out, it'll integrate seamlessly with your IoT devices, which when we get to the consumer grade, your devices will all synchronize together, right? Which we can use power line meshes internal to your house or your Wi-Fi's or things like that. So we have this whole new set of applications for business to business, especially when you start adding IoT, because let's say you have a supply chain where you have a refrigerated truck and you want to verify that, or over points of that, the temperature hasn't dropped significantly, and you want to verify that without a shadow of a doubt. Well, these IoT devices can actually report that. And when they have their own, simple little phased array antenna, they could even have a smaller one with less elements, because they won't need, as high of a signal strength, because it'll be lower bandwidth. These individual IoT devices can actually be self-sufficient, and anywhere in the world, they can, start giving you that access to supply chain data, which is going to be really important to, realizing this vision of, blockchain being used in all these different areas with, supply chain, or, even a smart lock, right? Like keys can all be picked. You can pick a lock from any key. Like, I mean, there's only one lock with the type of weird way that it does it. I don't know if you've seen, right? And so why aren't we using cryptography on that? Like, I should be able to say, hey, when you have your identifier, Dad, and I, say, hey, you come over today at 4 o'clock, I'll set it in my smart lock. You can go in, boom, access, and it opens up with your cryptographic identifier, right? Which then ties in with your IoT devices. So, the IoT and the Cube satellites is a really important first step, especially since the IoT device security is really, really subpar because everybody's rushing to get to market. This operating system will really help people get to market much quicker and with high levels of security, and it will automatically interface with the satellite constellations so that you can augment your IoT devices with the Phantom Cloud for business to business, or, for your own shared hosting services with, the Sirius Cloud and things such as that. So I kind of want to add a little bit of color to that, and that's how it's going to go. And by 2024 is when we're planning to be full production ready, which, Phantom's going to be having the launch capacity at that point, and we'll be having the software, well formed enough, and, with a large enough geographic coverage that, people will be able to start deploying their own satellites. So post 2024 is what our timeline is for, to open the system up where anyone will be able to start deploying their own satellites and developing their own tokenization systems. The second question was, can we use Starlink phased array antennas? Use 12 gigahertz? No. There is Atlas, though. I don't know. There's a specific antenna company that does do variable frequency phased array antennas. I don't think we're specifically going to support variable frequency, just because the antenna elements have to be spaced a certain distance apart that's proportional to the wavelength. So, 12 gigahertz is going to be a slightly smaller wavelength than 5.8 gigahertz. So you're not going to get that actual, it's not going to resonate with the antennas. So 12 gigahertz antennas for Starlinks won't work. But, as my father said, the Starlink does kind of have a failing or a not so great economic model, which, in some ways, if you look at the terms of service, it seems like Elon's more using it as a bargaining piece to get sovereign land on Mars. If you saw the terms of service where you admit that, Elon is a custodian of Mars and whatever. But, they're still a linear value stream. And what we're doing with this is we're demonstrating a cooperative system, and we're starting it with, Phantom and Sirius and Nexus kind of starting this, original cooperative alliance, and demonstrating to people that it's more profitable to have cooperative economies instead of competitive economies, where competition is the main driving force. When you make cooperation the main driving force, it exponentiates the value, and competition can become a subset of that, right? So, it really is, in order to change things, you got to create a new model that renders the existing model obsolete. So this not only gives people connectivity in different areas of the world, but it gives businesses lower barriers of entry to access satellites. You have different imaging systems. Even simple things like flat earthers. Hey, we'll show you the earth isn't flat right here. Take some images, have your own verifiable imagery, or even, our own mapping systems and things such as that. So I wanted to really clarify that. And then we have, please comment on the potential of terrestrial peer-to-peer ISM radio transceivers in the event nation states decide to cause issues with the satellites. For one, since we're using 5.8 gigahertz, it's actually a strategic frequency as well, since everybody uses it for Wi-Fi. So it's really, for one, it's going to be very difficult to try to tamper and interfere with it. You can send interference patterns into it. So one thing that we're going to be looking at as a further down research is optical communication, and potentially optical communication between crosslinks, because you can get really large bandwidths from it. And then another interesting kind of long forgotten technology is what's called ground waves, which right now we have what are called surface waves, or airwaves, that they pass through the airwaves. The carrier wave moves through the air. And then you have what are they called? Ionosphere waves, stratosphere waves, where they bounce off of the top ionosphere. That's another type of wave. And then there's ground waves that actually hug the surface of the ground. And the person that originally started this technology is, guess, Nikola Tesla, right? Nikola Tesla's Wardenclyffe Tower was originally designed as a communication tower, and he was using a low frequency, like 12.5 megahertz, but he found out that at a certain frequency and certain voltages, and with a certain grounding, right? The grounding is really important. You can actually send waves over the ground. And that's why he would light light bulbs up in the ground, right? He was transmitting power wirelessly through the ground, because the ground is the negative plate. Earth is like a capacitor. You have the negative and the positive in the upper ionosphere, and it's like a big capacitor with the Schumann frequency. So when you get these ground waves working, then we can actually, have certain ground-based infrastructure that can start providing some of those routes too as a backup. And it doesn't have the line of sight problem, where when you have towers that go through the airwaves, eventually that tower is going to hit that curve of the Earth, and you're not going to have line of sight anymore. So you really have to build these towers up a certain height in order to get that distance, let alone, the actual signal strength. So Zenit ground waves are something that we're looking at as research. There's a few companies that have actually started replicating that. Visiv Industries in Texas actually has a functioning Zenit ground wave generator, which is a half dipole generator. So that's one thing that Sirius Technology and Research is going to be doing. Is it's kind of like going to be the Bell Labs, an open source Bell Labs, where the funding from the tokenized satellite and the Sirius constellation is going to therefore go back to token holders, and it's going to fund further research so that we can start working on these really interesting new types of technology that are going to really allow people to take these things to the next level of tomorrow, right? And I think we have, with the new decentralized infrastructure, be interoperable with the current infrastructure. Yes, this new infrastructure will interoperate with the conventional IP. It's going to start off as an ad hoc network, and interoperating with IP is going to be really important, so that you'll still have full usability without full ground coverage, because it'll take time for when satellites to be deployed, and for ground infrastructure, mesh infrastructure to be deployed. So we need to interoperate with the internet at some point so that it becomes an ad hoc. And since it's going to be done with the one stack, you'll have just the same common identifier to send to somebody, whether it's over IP or NP. The locator layer handles all that for you. So you really just have to worry about sending to an identifier, and you cryptographically authenticate that packet and that person's input, so that you can verify that you're talking to the person that you're talking, and then weave that in with the operating system and all of the other different security measures. It's really designed to kind of take that privatized space, and to really realize, like, in my opinion, I could be wrong about Elon too, but I've seen him, it's supposed to be privatizing space, and in some ways it is, but from what I've witnessed, it's kind of taking NASA contracts and repurposing them. And like the civilian aspect of civilian access to space, really, I don't think has been fully realized. And that's something that Phantom and Nexus and Sirius are really going to be focused towards, is democratizing that space, and since there's this renewed invigoration, and in the name of Ernie, and I always repeat this, but he says, they killed children's imagination. If you remember his big pirate ship and floating stuff, that's like the beginning of that reawakening of the imagination. And the space there's something about space that just reawakens people. It's the new frontier. It's the new, and it's something that there's just infinite new possibilities. And that's something that's really important with us taking back our sovereignty as, a society, is we need to be able to imagine what the world can be like when we're not held in this economic disparity, right? Like, and, space is a really important thing to start that seed, So I think that's pretty much all the questions that I got. Cool. Well, thank you very much for your time. Dad, do you have any other comments that you want to do? I think we got Tash coming in about 3 or 4 minutes.
This is great. No, I really pleased with all the support from the Nexus community, and what we're doing here is pretty revolutionary. So Colin and I are hand in hand on this one, and look forward to seeing this evolve.
Yeah, the revolution has begun.
Exactly.
Yeah. All right.
All right.
Cool.
Thanks,
well,
guys.
Thank you.
My pleasure. Good seeing you.
All righty.